Welcome to my channel. Please subscribe. Encapsulation and data abstraction. Encapsulation and data abstraction are two of the fundamental concepts in object-oriented programming. Encapsulation refers to the bundling of data and methods that operate on that data, while data abstraction refers to the hiding of implementation details from the user. Together, these concepts form the foundation of object-oriented programming by promoting modularity, flexibility, and code reusability. In object-oriented programming, the concept of an object is central to both encapsulation and data abstraction. An object is a self-contained entity that encapsulates both data and the methods that operate on that data. The data is encapsulated within the object, meaning that it is hidden from outside access and can only be manipulated through the object's methods. This provides a level of security for the data, preventing it from being accidentally modified or corrupted. Data abstraction builds on the idea of encapsulation by hiding the implementation details of an object's methods from the user. Instead of exposing the inner workings of the methods, only the input and output of the methods are visible to the user. This provides a level of abstraction, allowing the user to interact with the object without needing to understand how the methods work internally. Encapsulation and data abstraction are closely related, and both are essential to developing well-organized and modular code. By encapsulating data and methods within objects and hiding implementation details, developers can build more robust and scalable systems that are easier to maintain and extend over time. In summary, encapsulation and data abstraction are key concepts in object-oriented programming that help to promote modularity, flexibility, and code reusability. These concepts are closely related to the idea of objects and are essential to building well-organized and scalable software systems. State, behavior and identity of an object. State, behavior, and identity are the three fundamental concepts of an object in object-oriented programming, OOP. State refers to the current condition of an object at a given time, which is represented by its data or variables. Behavior refers to the actions or operations that can be performed on the object, which is represented by its methods or functions. Identity refers to the unique identity of an object that distinguishes it from other objects of the same class. This identity is usually represented by a unique identifier or reference. For example, consider a car object. Its state could include the current speed, fuel level, and odometer reading. Its behavior could include accelerating, braking, and turning. Its identity could be represented by its unique vehicle identification number, VIN. Understanding the state, behavior, and identity of an object is crucial in OOP as it helps in designing and implementing classes effectively. By encapsulating the state and behavior of an object and providing a clear identity, it becomes easier to maintain the object's integrity and ensure that it operates correctly in the program. Classes, identifying classes and candidates for classes. Classes are the building blocks of object-oriented programming. They provide a blueprint or template for creating objects of a specific type. In order to identify classes, we need to analyze the problem domain and identify the objects that are relevant to the problem at hand. These objects can then be grouped together based on their common characteristics or behavior, and each group can be defined as a class. Once we have identified the potential classes, we need to determine which of these classes are suitable for our program. We need to consider factors such as the complexity of the class, its role in the overall program, and its relationship with other classes. Some classes may be too complex or specialized for our program, while others may not be necessary or redundant. In addition to identifying and selecting classes, we also need to determine the attributes and methods that will be associated with each class. Attributes represent the properties or characteristics of an object, while methods define the behavior or actions that the object can perform. By defining these attributes and methods within a class, we can ensure that each object created from that class has the same structure and functionality. Attributes and services, access modifiers. Attributes and services are two key components of an object-oriented program. Attributes, also known as properties or data members, are the characteristics or data associated with a class or object. Services, also known as methods or member functions, are the operations that can be performed on the object. In object-oriented programming, classes encapsulate attributes and services together into a single unit. Access modifiers in OOPS are keywords that determine the visibility and accessibility of classes, methods, and attributes. In many object-oriented languages, there are three access modifiers: public, private, and protected. Public access means that the attribute or method is accessible to all classes and objects in the program. Private access means that the attribute or method is only accessible within the same class. Protected access means that the attribute or method is accessible within the same class and any subclasses. Access modifiers are used to control the accessibility of attributes and services to other classes and objects. This helps to maintain the integrity of the object-oriented program by limiting the scope of access to certain methods and attributes. Proper use of access modifiers is essential for creating a well-structured and secure program. Static members of a class, instances, message passing. Static members of a class refer to the properties or methods of a class that are shared among all instances of that class. These members can be accessed without creating an instance of the class. Static members can be useful for managing common resources or behavior that needs to be shared among all instances. For example, a class representing a bank account might have a static member for tracking the current interest rate. Instances refer to the specific objects created from a class. Each instance has its own set of properties and methods that define its behavior. These properties and methods can be accessed and modified independently of other instances. For example, if we have a class representing a car, each car object would be an instance of that class and could have different properties such as color or make. Message passing is the mechanism by which objects communicate with one another in an object-oriented program. Objects can send messages to other objects, requesting that they perform a certain action or provide some information. The message may include data that the receiving object needs to carry out the requested action. In response to a message, an object may return a value or send a message back to the original object.